Alright, so if you add fractions back in elementary school or whenever you learn how to do that, you have to add common denominators first. Alright, and so that's the same deal with adding rational expressions, subtracting rational expressions. You have to have common denominators first. Okay, so well, these first two examples are going to be relatively easy because you already have them. Alright, but to do the next page, which we'll do in a moment, you're going to have to maybe watch the video again from before or look at these to remind yourself how to do them. It's from the middle of the last week if you need help with that. But really, right now we can just do these right off the bat before you don't have to do any prep work yet for these first two examples. So right here we have common denominators, 5 and 5 in this case. Okay, so what we do is you just add the numerators. Subtract the numerators in this case. So keep in mind there are implied parentheses around all these. So it's just really this minus this. So I'll show way more work than I would necessarily need to see. In the new numerator would be 3a squared plus 5 minus 5a squared plus 6a squared because we are, or 6a, plus 6a because we are subtracting the negative 6a. We subtract everything in the second denominator. So minus 5a squared plus 6a, because we're subtracting a negative, minus 2. All over 5. So we end up with 3a squared minus 5a, so it's negative 2a squared plus 6a plus 3. All over 5. Alright. You could divide each term by 5 if you wanted to, but that seems boring. I wanted to make sure you could do this part. Let's do another one. Okay. Technically, you should try to see if this factors. I made this problem up pretty randomly, so the likelihood of this actually factoring is pretty low. Alright, but you should check. And it doesn't. But let's do the next one. So we have the common denominators. So it's really just combining like terms in the numerator. So we already have x plus y on the bottom. When you add common denominators, when you add fractions, the common denominator stays the same in the answer. Okay, so what's x plus y and x plus y in the answer. So we get x plus 5x, we're going to have a 6x. 4y and 2y, we have plus 6y. Okay, and so did the x's, did the y's, plus 2 minus 2, so plus 0 actually. The 2's cancel. Boom, boom. Plus 2 minus 2, you get plus 0. Okay, so in fact, I made this a little too long. So let me do that. So what you should always do is what I said to do up here. Up here it's not factorable. You multiply to make negative 6, add to make, there's nothing that works. Okay, similar deal here, you can factor and cancel. This is 6 times the quantity x plus y. You can factor out a GCF here. And then, lo and behold, change colors to signify up, cancel, cancel. That big hot mess is just 6 over 1, so just 6. Okay? Alright. Now, if you don't remember how to build common denominators, you might have to look back at old homework, look at section 6.1, because that's what we're doing here. Okay, 2 examples. So these are relatively easy ones. We'll do some more difficult ones together in class. But these can get you started on the ones where you have to make common denominators. So what do we multiply by to get to the bigger denominator? So 2 times 2 gives us 4. So I get better times 2. And then I need to multiply by times x. So I better do that to both things. So we have to rewrite this. Okay, that equals, so we got to multiply by 2 and by x before we have common denominators. So what I've glossed over, and I think I feel like we need to concentrate a lot in class together probably, is that this is the common denominator. I made both of these kind of relatively easy because the common denominator is already there. Okay, we'll talk more about how you figure out what that is. You're just going to believe me that 4xy is the least common denominator. So we got to build up to that. Okay, so we're kind of doing easy example, less challenging example than some of them you might have to do on your own. We'll hopefully get to that, and we'll definitely get to that in class. So to go from 2y to 4xy, we got to multiply by the 2x. So to do that, what we do 2y times 2x, and we do 5 times 2x. So I do 5 times the 2x, and the 2y times the 2x. And then I wrote it wrong. 2x. 2y and 2x. Okay, so this 2 times x to go from the smaller denominator to the bigger one. That's what we do here. And so then we get 10x over 4xy minus 7 over 4xy. And this is exactly like one of the a problem from the previous page of notes we just did. We have common denominators. So once you have common denominators, that's the denominator it's going to have the whole time. And so you have, or at least unless you can simplify at the very end. So we have 4xy. Oh my goodness, I can't write. 4xy and then on top it's 10x minus 7. Those are unlike terms. We cannot combine them. We just leave it as 10x minus 7. That's the answer. Alright, so this one to find what the common denominator is, we actually have to factor this down here first. Okay, and this factors as x plus 3, x plus 2. Okay, if you don't believe me, you can verify. If you actually FOIL this out, you would get x squared plus 5x plus 6. Alright, that's what this is. Okay, so that means we better multiply by x plus 3. Excuse me, x plus 2, I'm sorry. X plus 2. Okay, so this equals, a little bit more space. Now, like I said, I've kind of made these not the hardest ones in the world just because we got to ease into it. These are tough. Okay. I'll write the factored form here. X plus 3. It's equivalent to what it has in the problem, it just looks different. That's what factoring is, it's just making it look different. Okay, and if we have an x plus 3 underneath the x, and if we're going to put an x plus 2 on the bottom of the first fraction, so we're going to we're going to multiply in an x plus 2. What I got to do to the top and bottom? So this becomes, so this plus this is, well, we should distribute, okay, so x squared plus 2x is what the first thing is. We have plus 3x squared. We have the same denominator, x plus 3, x plus 2. Come on, buddy. then we can combine like terms, and we're about home free. X squared plus 3x squared, so it's 4x squared plus 2x. And this becomes, now you should always check and see if anything's going to, you can reduce the fraction at all, but you cannot. It would be a heck of a coincidence because, like I said, I made this problem up, and usually you have to be looking ahead to make sure it can't, you know, you can do something like that. But anyway, you can factor out a 2x, nothing, you can't factor and reduce. You can't factor and cancel like we've been doing some in class. So the final answer is going to be x squared plus 5x plus 6 in the denominator, and then what we had to figure out in the numerator. And I'm pretty sure in the back of the book they tend to multiply stuff out. So they, I mean, technically you can leave it factored and it's really the same thing. But in the back of the book they tend to multiply it out, so I would recommend it. And there you go. A couple examples, hopefully that's helpful to at least get started on some exercises in class.